Every day, fraudsters are creating millions of new accounts with new emails and phone numbers, using those to send money from stolen credit cards. Doris missed a couple of physiotherapy appointments after surgery. 6 months later, she has to repeat the surgery. Power outages cost the global economy hundreds of billions of dollars every year. But did you know that advanced analytics on connected data or graph can solve these problems? TigerGraph's advanced analytics capabilities are combined with artificial intelligence and machine learning and used by the world's leading companies in financial services, healthcare, pharmaceutical, telecom, internet, e-commerce, manufacturing, and government organizations to address their challenges. 4 of the world's top 5 banks use TigerGraph to dig deeper into connected data to stop fraudsters in real time. The healthcare industry is mapping out the wellness journey for people like Doris, searching through millions of patients in real time to get them to critical appointments. Energy management companies are using real-time analytics to optimize power infrastructure and reduce outages for over 1 billion people. TigerGraph's native parallel architecture taps into the relationships to deliver deeper, wider, and operational analytics at a massive scale. Sign up today to see how you can improve your organization and the world with deeper insight.
Hello there, I'm Abhi, and let me walk you through Graph Studio, which is TigerGraph's visual interface. So in the Graph Studio, you can design your schema, which is equivalent to designing your use case. You can map the data. You can create loading jobs where the data always reside outside. It has to be fetched inside Graph Studio. You can load the data. You can explore it. You can visually explore it with respect to those people who do not do a lot of programming. They can create visual query patterns which can be used to explore the graph data set. And again, writing the query which pertains to your writing of the business logic. So with that being said, let me move you on to designing of the graph schema. The use case here is very simple. The use case is that the user have a bank account with a bank, and bank have merchant accounts also, and these are transacting among each other. And as you can see over here, there are attributes on each of this circle, which is called the vertex, and the line between them are called edges. And these payments are being performed using some devices. It could be a phone, it could be a laptop, it could be a PDA. And for these user accounts, we also know the phone numbers and the email addresses. So in a historical context of a fraud detection scenario, you may have cases which you have detected as fraudulent transaction, fraudulent user account, fraudulent devices, and you have already marked that into the system. So in our system also, we have some plainer and cleaner set of data, and on the other side, we have fraudulent set of data. Now, the idea here is going to be, first you bring in your data set into the system, and that is done using the creation of a loading job called map data to the graph. This mapping can be done visually, like you're seeing over here. Data is coming in from CSV files, but this data can come in from any source, which could be Spark cluster using our JDBC driver. You can use link to your RDBMSs to Hadoop and various different components. We have a well-developed ecosystem which is open source around the connector frameworks that can be utilized to fetch in the data into the system. So over here there are CSV files. Data can be very well massaged using our ETL capabilities that's built in, various different format conversions of the data set. And this data is preloaded into this graph database. Once the data gets loaded into our system, the next stage is always going to be looking at that particular set of data. So let's go back and explore one of the use case. So I'm opening up a user 37. So those of you who are new to the graph databases would right now, outright see the difference. Now, when I double click on this user 37, what I'm doing is not fetching the data from any different table using a foreign key. All I'm doing is bringing its one hop neighbor, which is linked with the edge, which are interlinked with this particular user. So it has an email address, as you can see, it has a user account and a phone number associated with this. And this user account should be doing a lot of its own transaction. And each one of this transaction is linked to another user account. and another device. So as you can see that we are not joining between the tables. All we are doing is hopping in the memory locations, getting all the edges associated one hop away from a vertex, makes it possible for graph databases to find pathways, to expose hidden pattern inside your data set. For example, now just by virtue of these interlinkages, this email address on the left-hand side has a path to this email address on the right-hand side. And this is the graph traversal, which is extremely useful in fraud detection for the financial industry or any other industry. What do I mean by that is that let me move on to a shortest path algorithm. A lot of algorithms are inbuilt inside TigerGraph, and I'm going to tell the system, find me the shortest path between these two users. And so there goes the system finding the interlinkages between the data set. It does not matter what depth you want to go to. It can be done in TigerGraph using 5, 10, 20, 30 depths and find this link between your data set. So this is the strongest use case of finding the path between the data set when it comes to list-based fraud detection or Frankenstein fraud detection. But you often need to do things beyond that, right? So let's move on to writing of the queries, where you write a custom logic where we will try to find all the devices in our system that has a lower level of trust scores and the payments associated with it. Let's say we are doing analytical operations, and now there is a custom requirement where we have to write this business logic of fetching all the devices which have been having a specific trust level score, which is low, and find the transaction which has been done using those devices. So for that, we need to write a GSQL code, which is very much like a SQL but Turing complete. What we are doing here is finding all the devices, writing these queries, writing a pattern, and then going in and finding the phone numbers and user accounts and who sends and who receives it, and ultimately prints it out. So let me execute this query, and as you can see, there is no caching involved. The system comes back very quickly, very fast, shows you all the results set, how the things are linked together. Look at this trust score of 0 on these devices. And these devices linked to this phone number have been associated with 2 different payments. So this is a payment, and this is another payment on the left-hand side. So if you look at this, there's any custom logic, which can be business logic, which can be fired, can be coded in GSQL, out-of-box capability of traversal, whether it's few hundred thousands entries in your system, whether it's million, billion, or trillions. We have everything in production, all kind of scale in production. With that being said, let me quickly show you one last thing, which is about Visual Query Builder. So a lot of the analysts at the front end are not technical enough, and they don't want to write programming of GSQL. So they can visually create these patterns. Here is an example of finding all the payments more than $100 done on devices which has higher trust score than 0.4, or user accounts which has higher trust score than 0.4. And all of this is performed using a Visual Query Builder. As you can see over on the right-hand side, you can set the different criteria. So let me execute it. The results what you're seeing over here are all the payments. If you look at over here, payments is $538, more than $100, and the trust score is more than 0.4, which we gave as initial criteria. So look at this scenario: Visual Query Builder, custom logic writing capability from GSQL, and graph traversal. So this is, in financial industry, you would see a lot of value for use cases like fraud, use cases like merchant analytics, deep link multi-hop analytics, and again, for the graph algorithms also. So when you structure your data inside graph format, you enable yourself to fire much more smarter algorithms like page ranking. You can find which merchant is more important than other. How do they rank with respect to each other? Community detection, based on merchant buying patterns and behaviors and user buying patterns and behaviors, how do they emerge as communities? And those communities may have some fraudulent transaction, and based on the highest fraudulent transaction community, based on your supervised learning algorithms, what you would run, you can detect the fraud rings, you can detect the marketing and sales possibilities in those particular regions, depending on how you are spanning your communities out. So there are a lot of possibilities here. We will recommend you to reach out to us at tigergraph.com. And we will be able to share our experiences around various different financial organizations. Remember, 7 out of top 10 banks in US around the world have been using TigerGraph as their core analytics strategy. With that, thank you very much and hope to see you soon.